Hey, Rani here. Shall we make a game? So I just gotta fire off this banger tweet. There we go. Done. So yeah, last time we were trying to implement collision, and we should be traveling from here to here, and for some reason we're ending up all the way over there. Anyway, I have at least had some revelations about what I can do a little differently. So last time I had this kind of potential problem in mind, something I was going to have to deal with. So let's say I have a triangle and it's got a very, very thin wedge-like end here. Right, so then we have this movement here. Let's go with that. Now, it intersects here, right? Meaning that this effectively becomes a movement along there, like that. And this then poses a problem because, if we're doing any kind of say something like that, we can then, it needs to push the kind of sliding collision path back into the triangle to avoid this thing where it's kind of like half in, half out, with rounding error. And I was like, well, if you push it back into the triangle, you could end up pushing it back out of the other side, right? That's a bit of a problem. And basically, as soon as I stepped away from the problem, I realized what the actual solution was. Don't push the the ray into the triangle. Instead, extend the triangle. Because that way you can't ever be pushing the line out of the other side if you've just made it bigger. So that's one of the things I'm going to be doing first of all. I have been doing a small amount of cleanup in here. However, it's now prefixed differently because the engine now has a name, which I'm going to share at some point, probably when I open source it. So yeah, there's a bit in here where we can talk about, the origins outside the triangle, force it in, don't need that. And we can now get rid of that. That's fine. That's fine. All right. So there should be a bit in here that needs thinking about. There should be a bit in here. Yeah, here we go, where we're checking whether it's kind of over the line. And the way we're doing that is by, we're checking if we're basically taking a point, comparing this to here, and then comparing it to this, and then basically comparing it to this normal using a dot product. So rather than comparing it to 0, which checks that it's in the plane of this line, we're instead going to check it, compare it to say 0.005 or something. So it's actually comparing it with a very slightly bigger triangle. And then when it comes to actually, say, reprojecting a motion like that, it'll actually put it on the edge of the triangle, meaning that it's just within the kind of like expanded boundary. So I'm going to make a constant for this. I've also removed all the _t suffixes, so we're finally POSIX compliant. Not that means anything whatsoever, given that we're not even running this kind of like within a native application that's sandboxed. Okay, what do we call this? Edge tolerance. That'll probably do. That's probably enough. And let's move it to the top. I'm probably going to need to do the same thing with the floor as well, the surface collision. That's fine. That's good. We can do that. So yep, we just do that. That's all we do. Now, we do have this missing division by 0. I need to think about that, as we still probably haven't actually solved that. This probably isn't going to do anything different at the minute, because whatever bug is causing this is probably not going to be fixed. Nope. Something I do need to consider is, at the moment, crossing into neighboring triangles isn't implemented, meaning it's probably projecting this point onto this edge. Which still wouldn't put it over there, but that's probably at least part of the reason it's going a bit weird. Let's instead check whether there's a neighbor over that edge. Where do I keep that information? I'm trying to remember. Oh yes, I keep it in its own array, don't I? Yeah, because I know exactly why I've done that. It's because I'm going to be hitting that information pretty. Hang on. It's that one. I'm going to be hitting that array pretty hard when we're doing like flood fill searches to try and find a path. So yeah, I put it in its own place. So let's just get it pointed directly to it. What do I call it? Triangle edge triangles. Wow, that is quite a name, isn't it? Okay, triangle edge triangles. Something else I'm probably going to have to do is, because at the moment this is basically like a set of flags that come out of the other end of the collision, which tell you, did it hit the surface? Did it hit an edge? We're probably going to have to also put a thing in to say whether it crossed an edge so that AI knows whether to like reevaluate its path. It knows, oh, I'm in a new triangle. I might be able to find a new path. Okay, let's extract. What's it called? Triangle edge triangles. There it is. Yeah, and it's the triangle index. Do we have a triangle index? That's the one. I think we multiply it by 3, and I think I'm still using the old prefix. That habit hasn't died yet. Expression must have pointed to object type, but has type unsigned int. What? Huh? What do you mean? Oh, that's what it means. Yeah, it means that I was trying to use a number like it's an array of numbers. And right, if the neighbor is still using the wrong prefix, it's going to be doing that for a while. If it's none, I need to be able to break out of this into this add loop for the iterations. Oh, I can choose continue for that. Right. So yeah, if we don't have a neighbor over that edge, then collect this information. Otherwise, continue on to the next iteration. And also we are going to record which triangle we have moved into. Should be very similar for this, except it'll be +1, because now getting the BC connection rather than the AB connection. And I've got 2 of our neighbors set up, and it should be just this one now. To be a CA line. Now, it's probably still going to be broken. However, it's going to be differently broken when I do this. Oh, didn't like that. Expected expression. What do you mean? That is an expression, isn't it? What do you mean you expect an expression? It's... Well, maybe I need to wrap this in braces because I am declaring a variable. And I seem to remember at least one language you had to, you couldn't basically have declarations directly within a... directly within kind of like the body or something. So let's do that. So directly following a case statement. Oh, that was it. Well, that was a very cryptic way of telling me that, see? Yep, that didn't change a damn thing. Okay, so now one of the annoying things is because we're not running this under anything with a real debugger, we don't really have any way of seeing what this is seeing. We don't really know why it's doing that specifically. Let's try something a bit less adventurous. Let's make the endpoint a bit closer, just so we can get a better idea of what's happening under. Yeah, because at the moment it's quite like an extreme condition. It's it's very rare that in reality you're going to have like a character model jump that far in one go across a collision line. Let's go to it's not a script. It's the movie theater script, isn't it? Yep, it is. And oh wait. It is this script, but this isn't in the script. This is basically just me messing around in a completely unrelated file. Let's get our Blender scene open. Let's add a new vertex. Let's add one kind of here and get an idea of as to whether that's crossing an edge correctly. Let's grab the coordinates. Make a copy of this. And let's see where that ends up. Okay, it's still off in Crazy Land for some reason. Okay, cool. Also, I love this, how this line is kind of interpolated. It hasn't, done something rational, like say, step down halfway along. It's done that. It's gone like all the way along the top pixel and gone like, yep, I'll just go down a pixel now. Okay, so we're still ending up in Crazy Land. Oh, I think I know where that is. If I drew a line from there, hang on, let me just draw a line to 0, 0, 0. I bet it would be, and then we're going to look for the eyes of the camera. Yeah, that's where it's going. We're just not setting a coordinate. It's just basically going from the start point straight to 0. Okay, that makes sense. That makes sense of why it's going all the way over there. I couldn't quite think of a rational reason it would. Okay, so next up we need to figure out why is it doing that. Most likely, I am not initializing a variable. We have this result here. Are we actually ever setting that to anything? We are here if we're not crossing an edge. But that seems quite unlikely at the minute. And we're not doing that here. Okay, right. Okay. So I need to output the coordinate here. And I probably should also constrain it to the current triangle just to stop it kind of leaking out. And I've got the thing there. I'm going to be selecting it. Oh yeah, I also got to change the actual sort of contract of the function just so it's able to output what you're colliding with. Okay, it's ended up there, which makes very little sense, but it makes more sense than over there did. How is it ending up there? Okay, next question. Is it possible that... No, we're not intersecting the surface. Okay, we can rule that one out. Right, so next up we can now see which one of these edges it thinks is the closest. I'm also just going to temporarily delete all of the triangles. And let's just see how that kind of looks in context. Does it do something equally irrational, or does it do something a bit more rational? Oh, it didn't like that. Unexpected L in OBJ state 0. Hang on a second. Nobody gives me the L. Okay, so that's the initial state. Let's have a look at our OBJ file. So it's going to be right at the start of the file pretty much, right? Or something. Oh, it's a line primitive because I drew some lines on it. Okay, gotcha. I didn't know that you could do that in OBJ. Okay, what does that do? Right, so it looks like it's not quite correctly colliding with the wall and it's ending up there somehow. So, hmm. Need to think about this, and yes, it hurts. Okay, so it's probably hitting one of these, right? Let's find out which one of these it's colliding with. It should be, looking at the colours, AB. It should be hitting edge AB. Let's go and mark this up as the edges rather than just random letters that have very little to do with the edge names. Yeah, it should. Should be hitting edge AB. That means undeclared. Declared it right there. Oh, wait, hang on. I'm still using the wrong prefix. Starting to regret naming the engine something. Okay, it crashed. We actually expected it to crash. Let's have a look at the inspector. Let's see where it ended up. It crossed edge AB. That's good. That's what we expected. Okay, does it do anything else? It then crosses edge BC. Okay, so that might be... Let's just... I'm actually going to make it quit immediately here. I just want to see exactly where it ends up after the first collision. So it actually ends up in the right place. It actually ends up kind of like sliding along the wall. But then it somehow ends up at BC, which is red, green, blue. It's that edge. That's not right. Okay, let's see where the origin point lands, because that's more likely to be the issue, I think. Oh, the origin point doesn't change. Hang on. Oh, unless it's underneath this line. Give me a sec. I'm just going to get rid of the... What colour is the line? It's yellow and magenta. Be gone. Huh. It's just gone. How about that? So that looks like it didn't update the origin for some reason. Huh. Let's go put a do on that so I know to remove it in a bit. So I think that's our issue. Our origin point is going somewhere. Can we figure out where, maybe? Let's just move it up a few pixels, because it's possible it's occupying a single pixel and disappearing. I think I specifically put a thing in so that couldn't happen. Yeah, I'm pretty sure I did. Okay, so we're somehow losing our origin point. So if I comment that... Wait, hang on, I don't actually need to do that. Right, okay. Man, what was I doing here? This is completely wrong. So I'm creating this uninitialized variable, right? And then I'm just subtracting the origin from it. I think that was an attempt to offset it along the, to push it back into the triangle. And I don't really know where I did that now I'm looking at it. That's more like it. It's still wrong, but that's more like it. So where's it ending up here? It's ending up kind of here. Ah. Hang on a second. Because we've got here the distance along the line. No, wait, that's not, that's, I think it's normalized, isn't it? Yeah, it's normalized. So that should, hang on a second, that should be landing directly on the line, but it's not. So that's interesting. Let's have a look here. So it's the distance inside the surface. The inside difference is the origin. Okay. So that should be like, let's just draw a picture so we can kind of like explain to ourselves what's going on. We've got a triangle and we've got a point inside and a point outside. We have a normal going this way. So if we take the difference from, hang on a second. Yeah, so it's the difference between that point and say this vertex. And we then dot product it with that, which should get us say -2. Yeah, if it was two units inside the line. And then we are trying to get the, and that's the inside difference, yep. And then we have the outside difference, which is the destination. Almost the exact same thing. It's basically this point, say subtract this point, dot with that, which should get us the amount outside. So that might be, for example, 3, at which point we'll have -2 divided by -2, take 3, which should be 2/5. So that would actually be correct, yes. So why isn't that working? Right, let's have another look at what it's actually doing. So it's, because it's meant to be projecting it onto this line. If I get rid of the code that actually adjusts the point at all, we can get a bit of a look at where it's Yeah, so the point is there, and we're somehow ending up with it there. And this number should be normalized, right? So it shouldn't really be able to leave the line, because like we've got a line from here to here, and we're basically like taking what should be a number between 0 and 1, using it as the linear interpolation kind of mix value, meaning that it should be landing somewhere within the line that we drew, but it's not, it's escaping it somehow. How would it be doing that? How would it be doing that? Why would it be doing that? Why would it betray us like that? And could it be that my maths is wrong? No, the computer must be wrong. Did we do anything else with this variable that we might be subtly corrupting it with? Doesn't look like it. Although that said, no, that looks right to me. Huh. That should be working realistically. Okay, let's for the sake of argument put 0.5 in there and see what it does. That's roughly the number I'm expecting. As you can see, with numbers between 0 and 1, we end up somewhere on that edge. Oh, hang on a second. Did we get this backwards? Oh, we got this backwards. Oh, my linear interpolation function's backwards. That's why it's ending up at, oh, my error. Okay, this should land directly on the line now. It's going to be slightly above because we're not pinning it to the triangle. So that's actually correct now. Okay. So that should... Okay. Let's compare that to where it's trying to go. And that should be a nice sliding collision along the edge of the triangle. Not quite, is it? It's not... It's trying to get to there, and then in the process, it's going to go all the way up there. It's somehow done a bit of force, multiplication. So let's drop it to one iteration, and let's see if we understand what it does. Okay, so that's about what I expected. But then if we go to 2 iterations, we'll see where it goes after that. Huh. I didn't expect that. I'll be completely honest with you. I did not expect it to end up over there. I wonder if this might be because of the 0 division thing we've got going on. I wonder. In the event that... Huh. Just making villager noises and thinking a bit right now. You know, it just occurred to me, and I can't believe it took this little thing to occur to me. I could actually just draw to the image from inside here. I mean, it'd be kind of like, you know, a gross breach of kind of like, you know, dependency principles and stuff. But we're doing it for kind of like the purposes of debugging, not for a final product. So let's grab our video buffer. Let's wrap all these in nice big to-dos because they're not supposed to be here. We're going to want videos. We're going to want we're going to want video images. We're going to want lines. We're going to want colors. We are going to want... We want cameras, aren't we? Why the heck did I put matrices in video and not cameras? Oh, well. We can fix that with the open sourcing, right? It gives us a real chance to kind of like go over the whole code base and figure out what went wrong. Okay, so I guess we've got to take a copy of our coordinate here and then transform it. Okay. Yeah, I'm going to make this less verbose for sure. The amount of times I've had to type that huge long word out. I seem to remember I had in here... Yeah, that's right, yeah. How am I going to represent this? And it's a float, isn't it? Not a not an integer, obviously. We're going to take our current origin and our current destination. And let's see if that makes any more sense when we graph it. I mean, spoiler alert, it's going to make no damn sense. We're going to look at this and go, oh my god, the problem is worse than I thought. Let's have a look. Huh. Okay. That's not what I expected. That's not what I wanted. Okay, so we were trying to go from here to here, and then we ended up going from there to there, which actually doesn't look that wrong. And then we somehow ended up over there, which is very wrong, just in case that wasn't obvious. So it looks like maybe the front at the end, the destination is kind of being squashed down onto the surface, which isn't quite right. What we're doing with the destination? Not that much, really. Because the first iteration looks right, and then it just loses its mind after that. Let's try it again with... Let's massively increase this tolerance to something that's like, you know, borderline silly. Nope, that didn't do it. All right, okay. Oh, hang on. That's wrong. We're reading the first vertex as all the others. That's probably a big part of the reason it was going so weird and wrong. There we go. That's still not right. But it's less wrong. And that's progress. Yeah, I was reading the first vertex and then going, oh, that's the same as the second and third, right? No, it's not. Okay. So it's hitting this, it's going that way. Actually, it's not even doing that. Oh, I need to move these ahead of the... No, I'm going to leave them where they are. So let's cut it down to one iteration again, see if we can figure out what's going on. And I'm just going to get rid of all of the... How is it ending up over there? Oh, actually, maybe that's actually correct. Let me put the vertices back in. Let's raise it up a bit and let's plug that back in. We are going to get to the bottom of this. It is going to happen. I think that might be bouncing off the floor and doing something kind of hard to understand, you know, from a static camera angle in 3D. Okay, so that's hitting that, and it's somehow going all the way up there. Why is it going over there? Next question we need to ask is, are we definitely, now that we're definitely getting the right vertices, are we definitely doing the right things with them? And the answer is probably no. So let's just check which edges we're actually hitting here, because I'm not sure. It should be hitting AB, but I'm not sure if it is. And let's put in the surface check just for good measure. Done it again, it's IE, not EF. I really need to change that muscle memory. Everyone know a good surgeon who specializes in muscle memory. I'm even typing the prefix in file names where it doesn't belong. Oh. That's kind of interesting. The the kind of code sort of safety check has gotten very confused there because it's saying this is an uninitialized because this line can't be hit. And it's like, yeah, but if it ever hits this line, it's not going to hit this line. Let's just put a to do on there. It is somehow hitting edge CA. That doesn't make any sense, does it? How is it hitting edge CA? See, that's more like it. It's somehow miscalculating this and seeing it as a collision when it is not one. Ah, hang on. 2, 2, 3. So that should be 4, 3. Aha. The last line effect has spread to the last line and the line before it. Okay, that's not correct, but that's less incorrect, which is better, I think. Okay, so what's happening here is, I can see what's happening here. I actually have the surface check the wrong way around. So it's actually checking rather than allowing. Okay, so all of these edges have the normal facing out this way, which kind of makes sense because you're crossing the edge that way. However, which means we're checking for when you're going in the direction of the normal. However, this triangle, the normal faces upwards, meaning that we actually need to check whether you're going negative, not positive, if that makes any sense at all. I don't know if it does. So we just need to swap these around, I think. So if the, hang on. Let's try and get this into my brain. Okay, so if the, hang on, if the start of, no, I just need to flip this around entirely. Okay, and at that point, hang on a second, I just need to rack the old brains here. Let's draw a picture, that normally helps. Okay, there's our surface. There's our normal, right? And our starting point is here, our end point is here. And let's just make these a bit more exaggerated in difference. Let's do the good old example. So this is going to be at 2, not negative 2, 2. And this is going to be at negative 3. Okay, so we actually want this to be the, again, it's the inside difference divided by the, oh, it still holds true, okay. Right, okay, there we go. Now it's hit the edge and it's going to slid along. So next up, let's increase our iteration count and see if it does anything else spicy. It probably shouldn't. It should see that we've hit an edge and stop there. And then it should be able to slide along the edge without hitting anything else. Okay, that's good, that's good, that's good. Now I'm going to roll back the changes to the nav mesh and do a build. At which point this might start doing something very interesting. Okay, it crossed over the edge without any problem. It collided with nothing. So next up, we send it back over to the edge of the nav mesh and see where it ends up. This might work, or pigs could fly. Hey, hang on. I think this might have actually worked because it's trying to go there, and then not entirely sure why, but it kind of diverted course slightly on the way. Let's have a look at that in a second. But then it hit this triangle and diverted this way, which is correct because it's almost kind of like going dunk. Okay, let's revert the blend file. Or is it there? It is. Oh, revert, yes. Let's have a look at where we're actually setting this coordinate and make sure that when we're setting it makes any sense. Is this the same one? 3, 1. Yeah, it's the same one. So let's draw a line between these two and see where it ends up. So it's actually, the reason for this diversion here is that it's actually colliding with this. And if I lift this up slightly, yeah, it'll be doing something like that. It'll be kind of bouncing off that edge and yeah, it'll be ending up sort of there. Okay, that's actually working, I think. Neat. I didn't really expect that, to be perfectly honest. So I can probably get rid of all this line drawing code, but there's still a few things we need to get sorted out. I am going to cap the iteration count pretty low, and you might be able to see what happens when I do that. So we're going to kind of like simulate what happens if we have, like I say, a large movement across a gigantic nav mesh. What it should do, but won't yet, at the moment, it'll do 2 iterations. It's crossed this, it's collided with the surface, and then it's just kept going. What we're going to make it do is when it runs out of iterations, it's going to basically just, basically hard clamp this point inside this triangle. And that's it. It's not going to be allowed to leave no matter what. Now, we did have some stuff earlier on when we were trying to find the closest point on the triangle, which was pretty tricky. But this is a bit different because, yeah, we need to, okay. So what got tricky about this was if you take like a triangle like this and you have a point, say, here, right? At that point, it's within this edge, but outside this edge. So you place it on this edge, which then puts it outside this edge. Now that's fair enough. You basically just end up doing like some extra checks. That was a little tricky to get our head around, but not that difficult. The bit where it gets a bit weird is we're now doing this in 3 dimensions, not 2. So you could, in theory, this is going to be really hard to visualize because, you could, in theory, have like a really kind of lent over kind of like nav mesh edge if you say have, like a triangle heading down there. You could have it, best example of this. Maybe a better example like that. You had a point that was, say... okay, here's the example. You have a point that's, say, here, and... Actually, it'd be there, wouldn't it? At which point it would already be outside of that. I'm trying to figure out if there's any kind of like cases where I'd need to look at 3, all 3 kind of like corners, but I'm not sure if there is. I guess I need to consider the two edges, and you know, I am thinking. I'm not entirely sure if it's possible for. Ah, right. Okay. So what might happen is, right, you might have a point underneath the surface here, so it gets raised up, and then it gets projected onto. Let's lean that the other way. Right. You have a point here. It gets raised up to the surface of the nav mesh, and then this edge here goes. Oh, I'll just snap that to me so it's not outside of bounds, and then you're at that point back under the surface. So at that point, you need to actually consider that you might. So yeah, oh my god, that does get really complicated because it's a lot of cases. Because it could actually be over 3 edges at once. Ah, okay, we can deal with that. Or it could be over none. It could also be over none. And so I'm going to deal with that first of all. And then the other thing we've got to think about eventually is the division by 0, which is, to explain what that is just quickly again, for my own benefit as well. What happens if, you know, we have this edge here and we start and end perfectly parallel outside? What do you do with that? Because, you know, how far away is that from that? And what do we use this for again? Distance to surface, do we use it for anything else? Distance closest. We use it to... okay. I'm going to need to think about that. Yeah, so what that's currently used for is... the algorithm currently expects that you're leaving the triangle like that, and therefore, if you take the intersection point, you can use that as the point to start sliding from next. However, if you're parallel, there's no point at which this line meets this one, meaning that at no point along this current line should you actually, you know, start your next collision. So I guess what I do in that case is actually project the point onto that triangle. Okay. Now I'm starting to see a use case for a function here that it would be used both in the very bottom of this and also here, because it's actually the same problem, which is you have a point that's outside of the triangle and you want to make sure it's inside the triangle. So we're going to solve that once. It's going to be a difficult thing to get right. Let's start off by making a function for it. Let's try and figure out what problem we're actually trying to solve here. Oh my god, I'm actually getting to the end of the stream. Oh dear. Okay. Constrain to triangle. And let's make it constant all round. Is it like that? I think it was. And it's an F32, and there's 3 axes on it. Okay, that's... We can just call that from down here and up here. And I think we have the current triangle in here. Yep, we do. Good. And we can also clamp the destination here. But we don't have the triangle here. We're going to have to get a copy of it down here. could be a different triangle to the last time. So yeah, we do have to... I was thinking, like, can I just reuse the triangle reference? The answer is no, you could have crossed an edge to get out. So you go there. That should do. Now this is going to complain about the fact we're not using any arguments in this function. That's fine. We're going to sort this out now. So, how are we going to do this? Well, we're going to need all of these. And we're going to compare, we're going to work out the distances to each one of them. Should be dead easy. Let's have a look at how we wrote this, because I'm trying to remember. It wasn't here, it was in the component file, wasn't it? Yes, it was. Wasn't the component file? I know I wrote it somewhere. Oh, it helps you go into the right component file. Okay, so that's right. We calculated the differences, and then we kind of like did this sort of tree thing where we went down, except there's going to be an extra level this time. Okay, so let's actually move this edge tolerance out into its own thing. Oh, actually, I'm not actually going to move the edge tolerance out. No, I'm not. Hang on, I'm just thinking. Distance to BC is bigger than 0.0. Else if distance to CA is greater than 0.0. Else if distance to surface is greater than 0.0. Except that needs to be that needs to be negated. I remember that. And was it the case that I needed all the branches and everything? Oh my god, there's gonna be so many. Okay, so to do project onto AB, to do project onto BC, onto CA. No, wait, hang on, we don't project onto... Hang on a second. Hang on a second. We project first, yeah, don't we? And then if the projected point is over an edge... Okay, all right. So here's the next question. Here's it's starting to get really silly, complicated question. Because our approach up until this point was, how did it go? Oh yeah, so it's kind of like, you're here, that gets projected onto this edge, it means you're now over here. We can easily detect that and go, oh, over there. But there's actually three different ways this can branch now. So it could be that you're just over this edge and then there's no correction needed because, you're not over this edge. It could be over this edge and then this edge when you weren't previously before. And then the correction to that could put you under the surface, theoretically speaking. In which case you would then need to also... Oh, hang on. Or would it? Yeah, if it's over this edge and it's over this edge, you would then end up not on a point like you were before, but actually a line extending out of here into space. And then we need to compare where we end up on that line to the plane, the surface. And if the point on that line ends up below the surface, that's when we use the... Oh my god, that ended up so damn complicated. This is going to be a problem for tomorrow, me, because this is... Yeah, how the heck do I solve that without, like, bucket loads of math? So I have implemented a system similar to this in the past, but it had a lot of bugs, and now I'm understanding why it had bugs. Oh, hopefully I solve these and I get a completely bulletproof collision, hopefully. All right, okay. Okay. Is there a better way of doing this? Because what we're ultimately doing here is we're constraining to a convex hull, right? Is there a better way of doing this? Because, you know, quite often people make a convex hull from like a list of points, but we already have the planes. Constrain points to multiple planes. Not intersecting, not intersecting. Keep points within multiple planes. Huh. Oh no. Okay, all right. So I'm thinking. Okay, so yeah, let's say we're looking down on this triangle, right? And let's say, for the sake of argument, we have perspective correction. And there's this line sticking out, right? And we're kind of here. And we end up projecting this way onto the plane of, onto this kind of like plane that we have here, right? We have this big plane like this, and we end up finding the point on the surface. We then check whether that point is over this plane. And if it is, we then need to work out where this line is, which will probably be a point and a normal, right? It'd be like a point and a normal going up. I wonder if we can pre-calculate that and cache it in the nav mesh. You know, just to speed up these kind of operations, because that's going to be quite complex to compute, I imagine. Well, we know where the point is going to be. It's going to be on the corner of the triangle. So the only thing we have to figure out is the normal. You know, so you know, if we say have our we have a triangle, and then we have, you know, we have this plane here. Let's just draw another triangle. Okay, so we're looking at a 3D triangle here, and we have a plane. I put bounds on it just for the sake of argument, but like it's actually infinite in size. But it might be that, say, it's a bit slanted over like this, right? We need to somehow find this edge. Now, I wonder, are there any properties of that edge that we can exploit? Like, is it actually, say, perpendicular to both of these? It could be. It could well be. Yeah, so if we I think, oh yeah, it might be actually. Yeah, so we could actually use the cross product, probably. I mean, probably. I have actually no idea what the hell I'm talking about, to be perfectly honest. We could probably get the normal of this plane, and the normal of this plane, right, which is going to be like that way and kind of that way. And then we calculate the cross product of them, and it would probably lean that way. At which point we can then do some like wizardry math, and we can use the distance between the point and this corner, dot product it with this normal, that we made by cross-producting these two, and it would get us a point kind of along here. We can then check if it's below. We can then check if the dot product is positive. If it is, we leave it on that line, and if it's negative, we place it below. So I'm just gonna make myself some notes for tomorrow because that's a lot of things to work out. Okay, so first of all, verify that cross product of two triangle edge planes makes a normal along the movie theater. no Visual Studio Code. Makes a normal along the intersection. Oh, hang on, plane normals. Makes a normal along the intersection line between them. Okay. And pre-calculate that. Time of importing the nav mesh, because we're probably going to be using that quite a lot in a few other contexts. And then if two edges are crossed, then we don't go blank now, don't go blank now, don't go blank now. If two edges are crossed, oh, I've gone blank. Right, use dot product to get distance from surface along that intersection line. And if we're 0, use it. If less than or equal to 0, use corner vertex. There's one more thing I need to consider here, which is what happens if, so we've got our triangle here, we've got the plane kind of extending up into infinity off it. What happens if we are both over this, on the other side of this plane and below the surface? Because at that point, we basically need to do the same thing where we basically, we need to also calculate kind of like the edge normals of, like AB, BC, CA. Okay, right. I've made myself a mess to deal with tomorrow. Thank you very much for watching and have a great evening.